to talk about today is just one more type of application for Riemann sum. So I'm going to kind of skip back to our example number 1. And if you remember, we had time in seconds, and then we had a rate of change. Okay, we had a speed there. And what we did was we kind of did an accumulation. We did an area under the curve, and what we came out with was an accumulation of feet. And so we kind of went backwards from a rate of change of feet per second to just feet. Okay, that's the main application of Riemann sums. Okay, so what we're going to do today is kind of use that same idea, but to answer a different type of question. Okay, so as I read through this problem and we look at the table, I want you to think about how is this problem different than the ones that we did. Because if you can early on pick out, hey, this is that other type of problem, then that's only going to help you. Okay, so this is number 3 on the notes. So in order to determine the average temperature for a day, a meteorologist decides to record temperature at 8 times during the day as indicated by the data in the table. Use a Riemann sum. So we know we have to use a Riemann sum. They tell us, all right, with the intervals indicated in the table to estimate the average temperature during the day. So far, how is this problem different than the ones we had been doing? They don't give us the graph. Could we draw our own graph, though, if we needed to? We could. What else?
I was going to say there's the relative extrema, because it's like an upside-down parabola, so you can have, like, the maximum there. And
so we'd have data that's not, like, always increasing or decreasing. Right. It's going to go up and come back down. How else? These are all good. There's many ways this problem is different. Look at this right here. Have we done that yet? We haven't done temperature. In fact, we haven't done temperature, but if this was degrees per hour, like the rate of change of temperature, that at least would be more like the problems we had done before. This is not a rate of change, first of all. Even if it was, though, it would still be different than the problems we've done, and the key here lies in 2 different things, okay? First of all, look at your time. We're not given that at 12 a.m. the temperature was this, and at 5 a.m. the temperature was this. We're already given an interval of time, okay? So, like, this is 5 hours right here. So typically what we see is maybe we're given the temperature at 12, given the temperature at 5, or they go ahead and write 5. Either way, that's different, okay? Is each interval the same? No. This one's only 2 hours. Okay, the biggest difference, though, lies in what we're trying to find. So before, we were given a rate of change, and we were asked to find, like, a total amount of feet, a total amount of miles. In another problem, it could be a total amount of people or total amount of gallons. We were asked to accumulate something. What are we being asked to do in this case? We're trying to find an average. And specifically, what they ask us to average is what's given in this table. Okay, we've been asked to find average rates of change before. All right, and you know how to just take average of number. But this is a totally new type of problem, and I'm hyping it up to be so different. But actually, what we do isn't going to be that different. But you've got to realize this is a different problem that they're asking us to do, okay? We're averaging what they give us. Now, if all of these intervals were the same, anybody have an idea of something really easy we could do to find the average temperature? Average all the numbers. And if those time intervals were the same, that's what we would do. That would definitely be easier than what we're about to do, although we're not about to do anything super difficult. But I'm going to go ahead and finish out the time intervals here. So 7 to 9 would be 2. What would 9 a.m. to 1 p.m. be? 4, 3, 2, and 3. And since I'm going from 12 a.m. to 12 a.m., what should all those numbers add up to? 24. So that would be a really easy way to check that you did that right. Okay? So I'm going to say this again, and I'm really making a big deal about this for a very big reason. We are not trying to accumulate and add up all of, it's not asking us for like, what is the total number of degrees over this 24 hours? They're asking us to take the average temperature during the day. So my answer should actually be a number that's like somewhere in amongst these numbers. It shouldn't be bigger than the biggest or lower than the lowest. It should be somewhere, not in the exact middle, but somewhere in there. Okay, so with all that being said, the way we're going to do this is actually not bad. They tell us to use a Riemann sum. Do they tell us left, right, midpoint, trapezoid? They don't tell us any of that. So we're just going to keep it super basic. In other words, and I could graph this, but we really don't need to. They're already giving us the height right there in that number 42. We're not having to pick left, right, midpoint. We're not having to do any of that. So I'm just going to multiply 42 times 5. Okay, that right there is going to give me a big number. So in the end, I'm going to have to think, okay, this is a Riemann sum. I'm doing the Riemann sum, but there's something I need to do at the very end of this problem. I don't want you to say it if you know it. But as we go, I want you to think, okay, this isn't your typical Riemann sum problem. So what is it I need to do at the end to kind of tweak my answer? Okay? So 42 times 5, that would give me the area of that rectangle. Okay? And the fact that they gave you a time interval, that's why we're just using 42. We're not like doing 42 times, you know, and then picking. I'm going to move on from that because I think I made my point. All right, so what would the next rectangle be? 57 times 2. Right, so once you get this, you should be able to fill out the rest. So go ahead on your paper. And if you got your calculator, go ahead and multiply and add it up and all of that. If you don't have your calculator, I want you to think about what type of number are people going to get in their calculator? A very big number. Okay, we started with 42 times 5 and we just added on from there. So is the answer going to be my final answer? No, that number would be way too big. Okay, so there's something we need to do to that number. It's a good place, it's what we need to do, but there's something else you need to do to make it be your average temperature. And y'all check my memory if this is right. I believe this is it. Okay, good. So there's no way the average temperature could be 1,584 degrees. First of all, that's not even Earth temperatures, but it's not within the range of the temperatures that they give us. So does anybody have an idea of what we need to do to this?
Can you divide by 24?
Who thinks that's a good idea? Yeah. Now you may, in the busyness of doing these problems, want to just call this your answer and move on. But if you think about it, you're going to figure out, hey, this number's too big. I need to divide by 24, and I get 66. Okay, and what are going to be your units on your final answer? Degrees. Well, we don't really know, but so I'm not going to put it because they don't put it. I agree. But they didn't list it, so I'm not going to list it. Right? Okay, so, because if you happen to be wrong, then that would be bad. So I'm just going to put 66 degrees. Now, I want to say one more thing about this. Let's say that you're like, I still don't understand why we have to divide. Okay, like why is that even an issue? Well, let's think about our units. What were the units on 42? Degrees. And so that was true of all of these big numbers. What are the units on 5? Hours. So our units on this 1584 should be degrees times hours. Don't think too hard about what does this mean in real life. It's not a common sense answer. Degree hours, what is that? Okay, that's fine. But we know that degree hours, our final units should just be degrees. So that's another way that you can think, hey, I need to divide by hours. Okay, and if you're like, well, how many hours? It's whatever your total interval was. Like, you know how sometimes my interval started at 0? Here it would end at 24 if the interval had been written that way. That's how you know what you need to divide by. Okay? All right, any questions on this? So what was your big clue as to this was, we're still going to do Riemann sum, but we got this extra little step and it's a little bit different. What was your biggest clue?
Use a Riemann sum.
It tells us, well, that means we're going to use Riemann sum, but it's because they tell us to find the average of this thing. That's how you know that this is one of these problems where you're going to have to divide. Now, there's a formula that I want to kind of just show you now, and I don't want you to get too freaked out by this, but this is something we're going to use later. All right, where this is 1 over b, and then the integral 0 to b. Now remember, this symbol just means area under the curve from this number to this number. So like on your homework, you're going to see this symbol. It just means do the same thing we've been doing. It's just getting you used to seeing it. All right, so like in this problem, it would have been like 1 over 24 times that whole thing. Okay, so that's kind of where we'll eventually go with this. I don't care if you write it this way or at the end, just know that it's divided by 24. For now, as long as you can get 66 degrees, I'm good. Now you're going to have a problem on your homework like this, and there's one part of your after party where you have to use this concept. Okay? That's the class.